Hello students, I hope you are having a good time. We are at section 3.3 of our book, that's derivatives, with our topic differentiation techniques. Today we will be learning about the product rule. The aim and objectives for this short tutorial is by the end of it you'll be able to find the derivative of two functions when they are multiplying together. You'll be able to apply these rules to any kind of algebraic functions, and you would know how to avoid common mistakes that usually students make while they do differentiation. So previously we have learned two techniques for finding derivative of functions. First was for power functions. Whenever we get a function in the form of x power n, we find its derivative as n multiplied with x power n minus 1. So we lower the original power by 1 and multiply the resultant with the original previous power. The similar way, we discussed that if two functions were added together and you needed to find the derivative of the sum, it would be the sum of derivatives. If you want to find the derivative of the difference, that would be the difference of two derivatives. But now, if two functions are multiplied together or two functions are dividing each other, what do we do in that case? For example, if one function is x squared and it is getting multiplied with another function e power x, how do we find the derivative of this? This is not an addition or subtraction at all. Or if first function is x squared plus 1 and it is divided by a linear function x, how do we do that? So in that case, we definitely need two rules. So the first rule that we today are going to talk about is the product. The product says that if you have two functions and they are multiplying with each other, for example, you name first function as f of x and second function as g of x. You are multiplying both of the functions and you want to find the derivative of the product. The simple way that you can remember this rule is that keep the first function as it is. So for example, you keep f of x, then you just find the derivative of g of x, then add the second term that you want to apply or give a plus sign. Keep the second term or second function as it is because you have already calculated its derivative, and now apply derivative of the first term. In your book, the same uh, rule has been discussed using this notation. For example, you are finding the derivative of the product of f of x and g of x. F of x is your first function, g of x is your second function. Keep the first function f of x as it is, find derivative of the second function g of x, then add a next term, keep g of x, which is second function, as it is, find derivative of the first function. We have discussed this already that for derivative we have different representations of notations with which we can show what a derivative is represented like. So if you are using the prime notation, you are putting a prime on the product of f and g. So f and g are two functions, they are multiplied together. You put a prime over them, that means you are finding a derivative of this product. So you keep f function as it is, put prime over g, that means find derivative of g, plus keep g function as it is, put prime over f, that means find the derivative of f. For example, we take this equation which says y is the product of x square and x to the power 3. Now these are two functions, one is the square function, the other is the cubic function. Let's name first function to be f of x, the second function to be g of x. We would need separate derivatives. F prime of x, we calculated it to be 2x. G prime of x, that becomes 3x square if we use the power rule. Now we are putting them in the structure where we say f multiplied by g prime plus g multiplied by f prime. We put the values and we simplify them. We get 2x to the power 4 plus 3x to the power 4, and the sum of which becomes 5x to the power 4. For example, we take another product where x squared plus 1 is multiplied with 3x. We name x squared plus 1 to be f of x. We name g of x as 3x. Now we find the derivative of f function, it becomes 2x. Find the derivative of g function, it becomes 3. Apply the rule which says f of x multiplied with g prime plus g of x multiplied with f prime. Put the values, simplify, and that's your answer. We take first example from your book. It's example 2.3.1. It says that find the derivative of this product. What product is given to us? It's a product of x minus 1 with 3x minus 2. So we have one function to be x minus 1, the other is 3x minus 2, but your book asks that do it in two separate approaches. First, expand this polynomial and then find the derivative using the polynomial rule. By expansion, it means multiply all the terms and simplify them, then apply the derivative. So let's do that. We take x, we multiply it with 3x minus 2, then we take negative 1 and we multiply it with 3x minus 2. We simplify the whole thing and the polynomial that we get is 3x squared minus 5 times x plus 1. If we apply derivative on it, the derivative of 3x squared should be 6 times x. The derivative of negative 5x should be negative 5. Now we are doing the same derivative but using the product rule. In product rule, we'll keep the first function same, find the derivative of second plus second function same, find the derivative of the first. If we do so, we will get this x minus 1 is kept same. We found the derivative of 3x minus 2, which is 3. We kept 3x minus 2 the same, and we found the derivative of x minus 1, which is 1. We simplify the whole thing and the answer is 6x minus 5, which is exactly same as what we did previously. So this confirms that the product rule is giving us authentic results. It is not wrong, it is valid by all means. When it is valid, it makes our life easier when we have a product of bigger numbers. If both of the terms are, for example, cubic polynomials or quartic polynomials or quintic or even of higher order, then multiplying them, simplifying the whole polynomial would be a tedious job. Rather, using the product rule, we can avoid all that labor. We get to the second example of your book. It says that for a curve y equals to the product of 2x plus 1 with 2x squared minus x minus 1. First, it is asking find the derivative y prime. Okay, we'll use the product rule. We'll take we'll keep 2x plus 1 same, derivative of the second function, then we keep take derivative of 2x plus 1, and 2x square minus x minus 1 is kept same. Once we have the derivative, it's this in second part it is asking that find an equation for the tangent line to this curve at point where x is equals to 1. Okay, now if x is equals to 1, we need to find the value of y as well, right? So first we will need the value of y. For that, we will put x equals to 1 in this y equation. As soon as I put x equals to 1, I will get the value of y, whatever value that would be. So at that point, I would need the slope of the tangent line, and then I'll need to find the equation of the tangent. C part is asking that find all such points on which the tangent line becomes horizontal. So tangent line is horizontal when its slope is 0. So we'll calculate the derivative and put that derivative equal to 0. If derivative is equal to 0, we know that derivative represents the slope of the tangent line. If the slope of our tangent line is 0, that means it is horizontal. Let's see how it does. So first we use the product rule, and this is the answer that we got. Then we need to find the tangent line at x equals to 1. So we need to confirm that what value of y we get when we put x equal to 1. We put x equal to 1 in the original equation and we get 0. That means the point at which we need to find the tangent line is 1 comma 0. So x value is 1, y value is 0. Now if we find the slope of the tangent line at this location 1 comma 0, we put the value of x to be 1 in the y derivative. Okay, we take y derivative and put x equal to 1 and our answer is 9. That means the derivative of the y function when x is 1 is 9. It means the slope of the tangent line at that location on the given curve should be 9. If I have slope and I have the point both given to me, so point is 1 comma 0, that means x1 is 1 and y1 is 0. We remember that the equation of a straight line when a point and slope is given can be given as y minus y1 equals to slope times x minus x1. If we put y1 to be 0 and x1 to be 1 and simplify it, we get the equation of the tangent line to be 9x minus 9, and this line will be tangential to the curve at point 1 comma 0. The C part asked us that what are those points where the tangent line has zero slope or it is horizontal. So we have already calculated the derivative. The derivative when simplified is equal to 12x square minus 3. We set that equal to 0 because derivative gives the slope of the tangent line. If the tangent line is horizontal, that means slope is 0. Slope and derivative are the same thing. Slope of tangent line and derivative are the same things. So derivative should be equal to 0. We solve this and we get two values of x as positive half and a negative half. If x is positive half, y will be equal to negative 2 if we put x in the original equation. If x is negative half, y will be equal to 0. So there are 2 points that we get, half and minus 2, half and 0. When x is half, y is negative 2. When x is negative half, y is 0. At these two locations, our curve will have a flat horizontal tangent. So the slope of the tangent would be equal. Next example is related to business. It says that a manufacturer determines that T months after a new product is introduced to the market, this number of products, x of t equals to t square plus 3t, 100 units can be produced. In t times, t square plus 3t, 100 units can be produced, and then they can be sold at a price of negative 2 times t to the power 3 by 2 plus $30 per single unit. Now we have price, we have total quantity. They are asking us to find the revenue. We know revenue is price times quantity. We will multiply both of the functions. That's good. Second, at what rate is revenue changing? At what rate means we need to find the derivative. For derivative, we will use the product rule. And then after 4 months, so we find the derivative, we put t equals to 4. And then they are asking whether it is increasing or decreasing. So it's very basic. If the derivative is positive, it is increasing. If it is negative, it is decreasing. Let's see. We found the revenue. We multiplied quantity with price, and that gave us this product. We need to find the rate of change, so we will take the derivative of this product. We keep first function same, find the derivative of the second, keep the second function same, find the derivative of the first. So we simplify it, we got our answer. We put t equals to 0 because we are interested in the change after 4 months. The answer is negative 14. Okay, so now my the quantity that we were producing initially was in hundreds of units. So that means the change is 1400 units, or when it is revenue, it should be $1400. But is it increasing or decreasing? It is negative, that means it is decreasing. Okay. One important thing that we in the beginning said that we'll try to learn to avoid the basic mistakes that people make, it is that the derivative of product should not be simply the product of derivatives. It is not as we do in the sum rule or the difference rule. In sum rule, we say that the derivative of sum is the sum of two derivatives. But in product rule, we do not say the same thing. It's simply you keep the first function same, find the derivative of the second, multiply them together, plus take the derivative of the first one and multiply it with the second function. Okay, let me walk you through your exercises. In the first 6 questions, you are given with a product, you have to find the derivative. So assume first function to be f, the second to be g, or name them u and v, or name them w and w. Use whatever names you want to and you are happy with, and use the same rule, you will be able to do well. Then in these 2 questions, they are asking you to find the equation of the tangent line at this specified point. So first you have x naught value, call it x naught or x1 or x0, whatever and suits you. In addition, find y naught value, right? So for y naught value, you need to put the x naught value in the original equation. If you put x equal to 0, you have -1 and you have 4. So the answer for y naught would be -4. Now you have a complete point. Just find the derivative. Derivative will give you the slope of the tangent line. In the derivative, put x equal to 0. You will have the slope. Use the equation that we have, y minus y naught or y1, whatever you use, equals to slope times x minus x. You use this one and you find your tangent line equation. Okay. Then it is asking you that what are the points where the tangent line is horizontal. So find the derivative, set derivative equal to 0, find the value of x. Put those values of x in the function, find the values of f of x or y. So you have all those points where the tangent line is horizontal. In this question, they have given you a quotient, means a function divided by another function, a rational function. They are asking you to use the quotient rule to differentiate, but we have not done quotient rule for now, so we skip part A. We'll be doing that later. They are asking you to rewrite the function as x to the power -3, because this 1 over x power 3 can be rewritten as x power -3 multiplied with the numerator term. Okay, if you write it like this, then you are able to use the product rule. Now use the product rule and find the derivative of it. Okay, if you wish, we can skip question number 41 for now, because we still don't know the quotient rule, so we are able to do half